So far, I've been solving all of my trig integrals using the relation sine squared of x plus cosine squared of x equals 1. And you might have noticed a pattern in all of these. In all of them, I'm using u substitutions. And on top of that, in all of them, I have odd exponents. Is there a reason I can't use it on even exponents? Let's pick something very nice and simple while I work through this question. I'm going to integrate sine squared of x dx. We've done cosine cubed, we've done sine to the power 5. Why not an even exponent? If I try my substitution from before, I can rewrite this integral and I get 1 minus the cosine squared of x dx. I at least know how to integrate that 1, but now all I've done is I've turned a sine squared into a cosine squared, and this second integral doesn't have a u substitution for me, right? I still don't have something for my du if my u is cosine. So this strategy doesn't look like it's going to work. It's important to be able to look at these problems and recognize when your strategy doesn't work. So I have to try something different. For the integral of sine squared, because my first trig identity didn't work, I'm going to try the half angle formula. So what is giving me problems in this integral? It's sine squared of x, and I want to replace it with 1/2 of 1 combined with a cosine of 2x. Well, what goes here? You remember? If I put a 0 in for x here, I'm going to get a 0 on this side. If I put a 0 in for x here, this is a 1. So I better have a minus. All right, cool. Let's put this in instead. I have the integral of 1/2 times 1 minus cosine of x, cosine of 2x dx. Well, that's looking a lot nicer. I know how to integrate this 1, and I know how to integrate this cosine of 2x as well. Check it out. Because I have the 2 times x inside the cosine function, I'm going to say that the most nested part of my function, the most nested part of my integrand, is 2 times x. So I will say that u equals 2 times x. A du is worth twice of a dx, or equivalently, a dx is worth half of a du. I'll go to integrate by parts. That 1/2 is staying the same, parentheses, 1 minus the cosine of u. My du is now a 1/2 du, like that. So I will pull these out. And now I'm integrating something very simple. My antiderivative of 1 is going to be u. My antiderivative of negative cosine is going to be negative sine. The 1/4 comes to the right, and I always need to remember my constant of integration. Last step, my u's turn back into 2 times x. And I'll distribute through. So the answer for this problem is going to be 1/2 times x minus 1/4 of sine of 2x plus constant of integration.